and welcome to Area of Shapes in our measurement series. So here's what we're going to cover in this one. We're going to cover a fair bit, working out how to find formulas for area, for new shapes that you haven't dealt with too much before, how to find the area of a sector, which is a part of a circle, and just some examples of area questions. Now, we're not going to cover, we're not going to memorize the names of every shape, every type of shape. We're not going to memorize every area formula. We're not even going to memorize any of them in this video. The reason for that is because you can look these up. The name you can look up in your textbooks. There'll be sections with diagrams of shapes. So there'll be the shape, the picture, the name of the shape, the formula, and there'll be all of that for lots of different shapes. You can look them up on the internet. There's lots of information. It's more important that you can use these resources until you actually remember them naturally. All right. So let's start with a basic definition of area, which is how many squares can I fit inside of a shape? Okay, so in this one, you can see there's 18 squares inside of this rectangle. The formula for the area of the rectangle, because I have 6 squares on the bottom, so that's in one row, and then I got 3 rows, it's really 6 times 3. And that is the base. This line down here is the base, and this line is the height. So it's the formula for the area of the rectangle is base times height. Now, in formulas, they don't use full words really. They just use the letters. So B times H, and really, they don't have this times sign either. With the letters, they just write them next to each other. This means B times H. These all mean the same thing. So, we'll be working out some formulas of some other shapes now. For example, let's look at this red triangle. Now, the red triangle is inside of a rectangle. And I'm sure you remember just from before, 20 seconds ago, that the formula for the area of a rectangle is B times H. Now, how much of the rectangle does this triangle take up? Hopefully you can see that it takes up half of the rectangle. So the area inside of here is a half of the area of the rectangle, which is a half of B times H. I've just written them all next to each other. It means a half of B times H. Or a half times B times H, same thing. All right, this is a little bit more complicated. You've got this rectangle that we had just then. You've also got another rectangle here. And in each case, it's the same thing. The red bit is half of the overall color. So the red bit overall takes up half of this rectangle. So actually, even though it's a little bit more complicated, it's still a half times B times H. So 2 triangles, we showed in 2 different ways that the formula for the area of a triangle is a half times B times H. Now, by the way, if I just had a triangle here without the rectangle, what's the B? The B is the base, this side of the triangle. And what's the height? The height is like the height of the triangle, which is this distance here. So it's still a half times B times H, the formula. All right. What's the area of this kite? This is the same kind of thing. The red bits always take up half of their little rectangles here. So overall, the area of this kite is a half times X times Y. This one, it's exactly the same situation, but without the little... I haven't drawn in the little rectangles, but you could still use the same thinking, and you could draw these lines yourself to show that really it's the same thing. The area of this rhombus has 4 equal sides, is a half times x times y. Now, what if you had a situation where there wasn't x and y? What if this was a and b? Hopefully in this case you should see that a and b are really the same thing as x and y. A is the same as y, b is the same as x, so that would be a half times a times b. Another thing you need to know about this diagram is that these lines over here, if I have lines through the sides, that means those sides are equal to each other. And if I had a shape like this, with a line here, and two here, that means these two are equal because they both have two lines, and these two are equal because they both have one line. Alright, this one's a bit of an interesting one. Here's a rectangle here. Okay, and that rectangle has same as any other rectangle, the area is b times h. But I could take this triangle off the rectangle, so let's get rid of it. And I can move it over here. So now we've got a different shape which is called a parallelogram. And sometimes they show you it's a parallelogram by doing these arrows. The arrows mean that these two sides are parallel. So they always go along next to each other. And these two sides are parallel, I could have one arrow. So I've made a different shape called a parallelogram. It's actually got the same area as the rectangle, which means if this is the h, this is the height of the parallelogram, then the formula must be the same as the rectangle, just b times h, because this area is the same as the area of the rectangle. It's this blue shape, this dark blue shape plus the light blue shape in both the parallelogram and the rectangle. Okay, so for this one, if you wanna get a little bit deeper into this one and think about this idea of the average of a and b, that's fine. Here's the area of a trapezium. We'll come back to this later in an example. Okay. Alright, now the area of a circle and a sector, this is different. So hopefully you remember from previous, hopefully you've learned this before. The area of a circle is pi times r squared, where pi is just this number that we run into when we're doing perimeter, which is around 3.14, and r is the radius of the circle, which is the distance between the middle and the outside. So for example, let's do an example. Let's say r is 5 centimeters. Then the area of the circle would be pi times 5 squared. Now let's use a calculator to work that out, because the calculator has the button that will show us what pi is. Well, it'll use pi in the calculation. So let's go pi times 5 squared. And we get roughly 79 centimeters squared. That means around about 79 centimeters squared. Okay, now if you have a sector like this, which is a section of the circle, this is very similar to a previous video. So if you haven't watched the video of perimeter of shapes with circular sections, then you should watch that. But really, we've got a section of the circle here. How much of the circle is it? Well, we work out how much it is by using the angle here. So the fraction of the circle is 60 divided by 360, because the whole circle is 360 degrees. And so that's the fraction of the circle that we've got. and we times that by the area of the circle. Now you can see that this is actually the same circle as this because the radius is the same. So it's the same area. So I times this fraction by the area, 79. And let's use a calculator for that. 79 times 60 over 360. I'll just use this one because it's already there. Times 60 divided by 360. Okay, so we've got 13, roughly 13. It's roughly equal to 13 centimeters squared. Okay. So what do you do when you need to find the area of a shape and it's a tricky question, you don't know how to approach it? Here's 4 steps. So you find the name of the shape, whether that's from remembering or looking up a chart. So then you look up the formula. You work out what the pronumerals mean, you substitute numbers. We'll go through those steps and explain them as we go. So hopefully you can remember just from a few slides ago that this shape is a trapezium. And we also covered the formula of a trapezium. I want to look this up quickly on Google and show you that sometimes the formulas are a little bit different. So this one says a plus b divided by 2 times h. Okay. What does this one say? It's different. It looks different, but it's actually the same. If you times something by a half, it's the same as dividing it by 2. This one has the h in a different spot. It has the h at the start, but this one, this one has the h at the end. Now it doesn't really matter, because if I multiply 3 things, it doesn't matter which order they're in. That doesn't change the answer. So often the equations will look a little bit different, but these 3 equations all mean the same thing. Now I'll use the equation that we had before, which is a half times a plus b times h. Let's write that down. All right. So the next thing is we have to work out what the pronumerals mean. Pronumerals are just a, b, and h. So what are these 3 things? H is the height, and a and b are these 2 sides over here. And a textbook will tell you that information as well. Google will tell you that information. You'll find some worked examples somewhere. All right. So a half times a is 3, b is 5, h is 2. So we have to do the brackets first. So that will be a half times 8 times 2. These are all times, so it doesn't matter which order we do it. Let's just do from left to right. So what's a half of 8? That's 4. And we have 4 times 2, which brings us back to 8 centimeters squared. Okay, so this is a good, this is just the way of finding the area of any shape. All right. So let's do this last example. Is it the last example? Yes, it is. Then we're on to the next topic. So find the name of the shape. What is this shape? Now, this might be a little bit tricky. This is actually the same type of shape as these sectors we were dealing with before. The difference is it's just a bigger sector. If I make this angle bigger, I'll make my sector bigger, and eventually, if the angle's bigger than 180 degrees, it starts to look like Pac-Man. So here we are, we've got a Pac-Man sector. This is a little bit of a tricky question though, because it tells you the 80, and so maybe you think, okay, my fraction is 80 over 360. But this is not the angle of the sector. The angle of the sector is actually this part, which is 360 minus 80. 80 is the leftovers, so we have to get rid of that. So it's the angle that we're looking for is 360 minus 80, which is 280, yeah. So that's the angle that we use in our fraction, 280 divided by 360. And this is the fraction that we use to times by the area of the circle. By the way, I'll just draw the 280 in here. Okay, so we have to times this by the area of the circle. And what's the area of the circle? Why don't we work that out over here? The area of a circle is pi times r squared. That's pi times 3 squared. Okay. So pi times 3 squared that's 28.27. Alright, so that's the area we use here. Alright, now let's work this out again. We had that 28.27, or the more accurate version, on the calculator already. So let's use that. Times 280 divided by 360. That's our fraction. And we end up... What have we done wrong? This is not good. This number is so much bigger than the other numbers, so it must be wrong. So we have to actually start again. Can we go back to... No, we can't. Let's clear it all. We had 28.27. Let's start again. The problem was we times it by 280 and then we times by 360 instead of dividing. So let's do it properly. 28.27 times... Oh, what's happening here? Let's go again. 28.27 times 280 divided by 360. And we've got 21.98. So it's roughly 22. This is roughly 22 centimeters squared. Alright, that was a somewhat long video. So let's go back to the start to make sure we did actually learn what we wanted to learn. Working out area formulas for new shapes, I'm not so concerned. If you can't do this, that's okay. Because what you can do is you can still look up the formulas and you can still substitute the numbers into the formulas and work out the area, even without this. I think it's nice, this sort of thing, and it helps us understand what's happening and it helps us remember the formulas, but if you don't understand that, that's alright. We worked on the area of a sector and we did some area examples. Again, keep in mind, use your resources, use your textbook, the internet, and try some questions and give it a go, and I'll see you next time for volume. Yep, for volume.